Hey everyone. So this is our last video around the rational unit, and it's rational equations and applications. It's probably the hardest stuff, and it's probably going to be the longest video when all is said and done, but that's partly because really, as we go through this, we're going to review some of the concepts that we did in the first videos as well, okay? So when you have an equation, and you have to solve for the unknown, whether it's x or a or b or whatever, because you get to work on both sides of the equation, there's a little bit more you get to do. And essentially the concept is we're still going to try and get a common denominator, okay? Now, your teacher may have not taught it that way. There are kind of two different ways to handle equations. One is you get both sides to be a common denominator, and then you just pull the numerators out. Okay. The other is that you multiply everything by a common denominator, and then that just leaves you with no fractions. It leaves you with whatever the numerators would have been. Okay. Both of them get to the same spot. Okay. So it doesn't really matter which one you do. I'll probably do both as we go here, just to give you an idea of each one. You just do whichever one you're most comfortable with and whichever one you get the right answer with. Okay. That's the most important thing to me. Okay. So to solve rational equations, we get to work on both sides of the equal sign. This allows us to get rid of the denominator. Now, be careful with that, because this is always kind of the trap we fall into, is we end with equations and we start getting used to just making denominators disappear. You can only do that if you have an equation, because you get to work on both sides of the equal sign. If you are simplifying something, if you're just doing the addition or subtraction or multiplication or division, you don't get rid of denominators there, okay? So all of those sorts of things we did in the last video, they all still had a denominator in the answer. Don't look at this video and then assume you can always make the denominators disappear. You can only make the denominators disappear like that when you're dealing with an equation, okay? Okay, so this can be done by first establishing the common denominator on each side of the equation and then working with your numerator, or multiplying each term by the common denominator. So once you have the fractions gone, you'll need to solve. Also watch for your NPVs and look for those NPVs, obviously, before you get rid of the denominator, because that's where the NPVs are found. And just because you get rid of the denominator doesn't mean the NPVs go away. Okay, so you always have to write the NPVs before you get rid of the denominators, because when you get down to an answer, you have to verify that the answers that you get aren't any NPVs, because if they are, they're extraneous and you can't use them as part of your solution. Okay. All right. Another way to solve is to graph and find the x value of the point of intersection. Be careful with your calculator. If you can't open up a fraction button, the top part needs to be in a set of brackets and the bottom part needs to be in a set of brackets. So if you have a newer TI operating system, you can open up a fraction first by pressing alpha y equals 1. That's alpha y equals 1, and that will open up a fraction for you. If you are a newer gray or black Casio, you can press your fraction button, which is the ABC button, or it just says a box over a box button. It's right on top of your 7. If you are an older TI operating system or a white Casio, you guys are the ones who are going to have to think about the brackets. So for example, if I wanted x plus 4 over x minus 3, I would have to enter that. If I'm an older TI or a white Casio, I would have to enter that as bracket x plus 4, close that bracket so that all the top is in one set of brackets, then divide by, and then all the bottom has to be in another set of brackets. Okay. It's also helpful to make one of your lines thick so you can distinguish between the two graphs you're looking at. If you have a TI, you can make one line thick by going just in your y equals equation, left click over until you get to the other side of y, and it will start flashing. And if you hit enter, it'll change that guy to a thick line. If you are a Casio, you'll press Tool and then Style, and then F2 will make it a thick line for you. Okay. Okay. With application questions, you'll be asked to come up with the equation or to solve an equation given to you. We won't ask you to do both in the same question. Okay, so either you have to come up with the equation or you have to solve an equation that's given. If given the equation, ensure that your answer actually answers the question. For example, your equation will solve for x, but the question might have been, what is x plus 4, right? And you see this a lot with distance, speed, time questions, and we will do these together in a minute. But make sure you know, once you get x equals whatever, you have to say, okay, what did x actually represent? And is that what I'm actually supposed to answer as far as the question goes, okay? All right, so here we go. The solution for x in the equation -2/3 minus 4/x equals 6. Okay, so we need to solve this. We need a common denominator. Or now a common denominator is going to be 3x. So either we just write all terms here. There's 3 different terms. Either we write them all as 3x on the bottom, or we just multiply everything by 3x. Okay. I chose to multiply everything by 3x. So I'm not getting a common denominator here. I'm going to multiply everything by the common denominator and wipe my fractions out that way. I will show you both methods as we go. Okay. So for this guy, I end up with 3/3 is 1. So that just ends up being -2x when I multiply all that together. Over here, my x's divide each other out and I'm left with -12. And over here, I'm left with 12x. Okay, so -2x minus 12 equals 18x. Sorry, I think I said 12. 6 times 3 is 18. Sorry, I don't know what I was thinking there. 18x. So now I'm ready to solve. I just have to add 2x to both sides and divide. So divide both sides by 20, and then I'm going to reduce that. So 12/20 would reduce to 3/5, and I had one negative there, so my answer is negative. Okay, so that's going to give me C as the answer. Okay, just take note that was a released item, so that came from an actual diploma. Okay, solve the following. Now, on this guy, I have a proportion, actually. I have a fraction equals a fraction. When I have a fraction equals a fraction, another thing I can do is just cross multiply. Okay, so I could multiply those two together and those two together. And essentially, that's just me getting rid of the denominators, right? If I multiply both sides by 4, I'm getting rid of the division of 4. If I multiply both sides by 4x plus 1, I'm getting rid of the division of 4x plus 1. Okay, I want to save my NPVs before I do that. So if I'm unsure of that, I'm going to go 4x plus 11 equals 0, solve for x, and that's where my restriction or my NPV is going to come from. Okay, so that'd be x can't equal -11/4. Okay, so if you like the cross multiplication thing, you can do that. What I did was I got a common denominator here for you. That was my other method. So I said, okay, my common denominator is going to be 4 times 4x plus 11. Well, what did I need here? I needed a 4, and whatever I do to the bottom, I have to do to the top. So I took that left side and multiplied it by 4/4. That's going to give me a common denominator. On the other side, I needed the 4x plus 11 on the bottom. So if I put it on the bottom, I have to put it on the top too. This conversation should still sound very similar to the whole adding and subtracting conversation we had in the last video, okay? It's the same thing. The difference now, though, is now that I have a common denominator, the numerators can just get pulled right out, okay? As soon as you get a common denominator, you can pull out the numerators. And the reason is, just conceptually for a second, if I said x/3 equals 7/3, well, there's no value for x that's going to work here except 7, because 7/3 has to equal 7/3. It can't be 5/3 equals 7/3. That doesn't work. So as soon as your denominators are the same, your numerators would have to be the same. Okay, and so what I've done is I pulled out my numerators, but at the same time, I did the distribution. So 4 times 5x gave me the 20x, and 4 times -1 gives me the -4. Then on the other side, I have 3 times 4x to give me my 12x, and 3 times 11 to give me my 33. Okay, now I'm ready to solve that. And so I just, sorry, I tried to get my ink off and I didn't have my mouse anymore. So I subtracted 12x from both sides and I added 4 to both sides, and that gives me 8x equals 37. Divide both sides by 8, and so x will equal 37 over 8. Okay, now I check that against my NPV. Okay, so I say, hey, that better not be an NPV, and it's not, so I'm good to go. Okay, and I gave you both forms here. On a diploma, they will specify how they want you to answer. Often they'll give you rounding instructions, so that's why I put the decimal beside it as well. 37 over 8 is 4.625. Okay. Just a quick, we might as well have a quick little conversation here around rounding. It really sucks in a numeric response question if they gave you rounding instructions and you did everything right, but you rounded wrong, because then it's automatically your whole question's wrong. So just be careful with that. If this was being rounded to the nearest, let's say 100th, that's 625. So the 5 would bump the 2 up to a 3. So that'd be 4.63. If this was rounded to the nearest 10th, I'm stopping at the 6, so I just look at the next number, which is a 2, so it would keep it at 4.6. It wouldn't round it up to 4.7. Okay? All right, good. Okay, let's try this guy. Solve the following. 3 over x plus 5 over 4 equals 3. You have that in your book. You probably don't see that because I'm in the way right now. So there is the question I'm talking about. Okay, and first thing I want to do is I want to talk about my NPV. So I know that x can't equal 0. Okay, and so now what I'm going to do is, again, I'm going to approach this by getting a common denominator. Okay, so my common denominator is going to be 4x. So I'm just wiping everything away by multiplying by that common denominator. Okay, so essentially this one does things in 2 steps. It does 2 steps in one. Okay, one way is just to write everything with the common denominator and then pull the numerators. This way is multiplying everything by the common denominator, which is essentially doing both of those at the same time. Okay, again, you do whichever one you like the best. I just want to kind of oscillate back and forth between the methods so that I'm getting your method accomplished, whichever method that is. Okay, so I'm multiplying everything by 4x because that's my common denominator. So I got the common denominator and now I'm multiplying it. Okay, so this is going to give me 12. This gives me, the 4 is gone, but then the x gets distributed. So that'd be x squared plus 5x, and then 12x on the right side. Okay, so now I'm ready to start solving what's left. It looks much less intimidating because there's no fraction there. But there is a square term and a non-square term, which means I have a quadratic, and I need to look at factoring this. Okay, so in order to factor, everything has to be on one side of the equal sign. So I'm going to bring my negative, or I'm going to subtract 12x from both sides. Okay, so that'll give me negative 7x on the left side, x squared minus 7x plus 12. I just wrote that in the proper order as well. I just brought the 12 over to the end of the chain. Okay, so now I'm looking for 2 numbers that multiply together to give me 12 and add together to give me negative 7. Those would be negative 3 and negative 4. And so x equals 3 and 4. So 2 possible solutions, but then I need to check them against my NPVs and make sure they're not an NPV. Neither of them are, so both of them are valid solutions. Okay. Now, what if we wanted to try graphing this? So I want you to go back to the original question, which again was right here. Okay, so you're going to put this guy here in y1. Watch your brackets, and you're going to put this guy here in y2, and you're going to look for the x value of the intersection point. Okay. Okay, so the graph that you can pause me to do that. The graph that you should have accomplished should look something like this. Okay, and then you will see that there was 2 intersection points, one at x equals 3 and one at x equals 4. Okay. Awesome. Okay, let's give this one a try, just in case you can't see the question. It's 3x over x minus 1 minus 4 over x equals 3. So I need to talk about NPVs first. X can't equal 0 and X can't equal 1. So here I am getting just first writing as a common denominator. Okay, I'm not getting rid of it right off the bat. So I'm doing the other method. I'm going to have everything as a common denominator. My common denominator had to be X times X minus 1. On the first fraction, I didn't have the X. So I stuck an X on the bottom, and then whatever I do on the bottom, I have to do to the top. On the second fraction, I didn't have the X minus 1, so I stuck it on the bottom, but whatever I do on the bottom, I have to do to the top. On the last guy, I didn't have either of them, so I had to put the X there, and I had to put the X minus 1 there. Okay, so now this, although it looks messy, that all has a common denominator now, which means I could just pull out the numerators. Okay, so this is going to be 3x squared minus, be careful of that because I kind of hit it with what I circled. That's a negative. So that negative 4 will get multiplied by x, and that negative 4 will get multiplied by negative 1. Okay, so I have 3x squared minus 4x plus 4. So that plus 4 came because it was a negative 4 times a negative 1. And then on the right side, I've got 3x squared minus 3x. Now I have that, I just kind of prettied it up a bit, and I've got my common denominator, so now I'm just going to pull the numerators off, okay? So I end up with 3x squared minus 4x plus 4 equals 3x squared minus 3x. All I did there was I pulled my numerators off. Then my 3x squares actually cancel out because if I subtract 3x squared from both sides, they're gone. And then I'm going to add 4x to both sides, and I get x equals 4. Okay, but I need to check that with my NPVs. Was that an NPV? No, it wasn't. So it's a safe answer. It's good to go. Okay. Next question, 2x over x plus 3 plus x over x minus 3 equals 18 over x squared minus 9. Okay, so I want to factor that x squared minus 9. That's going to be x plus 3, x minus 3. Okay, and then I want to state my NPVs. I can see that x can't be plus or minus 3, which that my there, x can't be plus or minus 3. Okay, so I showed it to you in fully factored form and then stated my NPVs. Now, my common denominator is going to be x plus 3, x minus 3. So either I just multiply everything by x plus 3, x minus 3, or I rewrite this as common denominators first. Okay, I chose to multiply everything by the common denominator, so x plus 3, x minus 3. When I multiply this first term, my x plus 3's are gone, so I'm left with 2x times x minus 3. On the second term, my x minus 3's are gone, and I'm left with x times x plus 3. And on the third term, both of them are gone, and so I'd be left with just 18. Okay. Now, I'll clean it up to solve. I'll distribute the 2x, I'll distribute the x. 2x squared plus x squared is 3x squared. Negative 6x plus 3 would be negative 3x. I want to bring that 18 over to be negative 18 so that it equals 0, and I can try and factor it. Actually, before I factor it, everything's divisible by 3 here, so I might as well do that and make my numbers a little smaller. Okay, so all I did between those slides, let me just go back there for a sec for you. I just divided everything by 3, so that's going to give me x squared here, negative x here, and negative 6 there. So now I'm looking for two numbers that multiply together to give me negative 6, add together to give me negative 1. Those are negative 3 and 2, which means my answers, remember, to get from here to my answers, I'm taking each factor and setting it equal to 0. It's the zero product principle. Okay, so x minus 3 could equal 0, or x plus 2 could equal 0, which means x is negative 2 and x is 3. Now, I need to verify that with my NPVs, and I say, oh, look at that. Nope, x can't be 3 because it's an NPV. Now, it's super important that you do both of these steps, okay? your marker is going to want to see you conclude that x equals -2 and x equals 3 first, okay? Then they want to see that you know 3 is not possible because it's a non-permissible value. So, and then they want to see you conclude the actual answer, which would be x equals -2. Okay? Awesome. Okay, you want to try graphing that? Totally do. Okay, so let's go back to the original. Okay, again, I'm just going to hide myself for a second so you can see the original. You're going to stick this guy in y1, and you're going to stick this guy in y2. Pause me for a sec so you can try it yourself. Either open up those fraction buttons or be very, very careful of your brackets. Okay, and the graph you should have gotten looks like this. And you can see only the one intersection point there at x equals -2. Okay. All right, so now we're going to move into some applications. Application is just a fancy way of saying word problems. The dimensions of a rectangle are represented by rational expressions where x is greater than 1, as shown in the diagram. If the area of the rectangle is 16 centimeters squared, determine the dimensions of the rectangle. Okay, well, how do I get the area of a rectangle? I go length times width, or base times height, however you like to say that. Okay, well, I've got a rational expression representing each of those. So I know that if I multiply those together, it has to equal my area, and I know my area is 16. So that becomes my equation. Length times width equals 16, okay? So now I need to work on solving this. Okay, so here's what I want you to think about with this guy. If I had given you something like, I don't know, 5 over 3x equals 7 and asked you to solve for x, you would want to get rid of the division of 3x, right? So you'd multiply both sides by 3x. So you'd get 5 equals 7 times 3x, right? Multiplying this side by 3x and multiplying this side by 3x, but your 3x's would divide out over there. Okay, we're going to do something similar here. So my common denominator, what I want you to see is it's x plus 1 times x minus 1. So essentially, I'm going to multiply both sides by x plus 1, x minus 1. That's going to get rid of the denominators on the left side, but it will put the x plus 1, x minus 1 on the right side with the 16. Okay, so that's what's happened here. Now, I'll distribute my 4x. So that'll be 4x squared plus 16x. Probably you want to do this first, but you might notice that as the difference of squares. So that ends up being x squared minus 1. If you're not sure of that, though, just FOIL it. So x times x times -1, 1 times x, and 1 times -1. Then we're going to have to distribute the 16. Okay, so when I distribute the 16, that'll give me 16x squared minus 16. And now I'm ready to bring everything over to one side so I can solve. I want to keep my x squared positive. So because this guy's the bigger x squared, I'm going to subtract the 4x squared, bring that over here, and subtract the 16x. So that's going to give me 0 equals 12x squared minus 16x minus 16. Okay? Now I need to solve that. I need to solve that quadratic. I divided everything by 4 first, just to make my numbers a little smaller. Okay, and now I'm going to graph it. So I graph that and I look for the x-intercepts because it equals 0. Okay, so on a TI, you would go, you'd have to put y2 as 0, and you'd go second trace 5, enter, enter, enter to get the x-intercepts then. On a Casio, you go g-solve root. Now, I got 2 here. Oh, I don't know what happened there, sorry. I got 2 here. I want you to notice that I've kind of ignored this guy, okay? And I've ignored that guy because he's a negative number, and I can't have a negative dimension here. And in the question it said x had to be greater than 1. So really, anything to the left of 1, I was told not to pay attention to, okay? So I know my answer is only 2 here. Now, this is a great example of something I talked about at the beginning. X is 2. Great. That's not the answer to the question. The answer to the question is, well, what's the question? Determine the dimensions of the rectangle. So now what we have to do is we actually have to put that value of 2 in for x and get the actual dimensions. So on the x plus 4 over x plus 1, if I plug in 2, I get 6 over 3, which is 2. And then on the base guy here, the 4x over x minus 1, when I plug in the 2's for x, I get 8 over 1, which is 8. Okay, so then I conclude the dimensions of the rectangle are 2 centimeters by 8 centimeters. Okay. All right. Well, solving the equation, 3 over x minus 2 plus 5x over 10 minus 5x equals 2, Kylie made an error. Her work is shown below, the first recorded error in Kylie's solution. Now, the one thing I want to bring up to you right away is it says the first recorded error. They do like to be a little sneaky here. They will put more than one error in so that if you don't catch the first one, you might catch the second one thinking that that's the first one, but then your answer's not right. So you gotta go very carefully, step by step, and make sure you agree with each thing. So in step 1, what did she do? Well, it looks like she factored out the 5 from this 10 minus 5x, and that she said that was 2 minus x. Okay, that looks pretty good to me. I'm happy with step 1. Step 2, looks like she canceled out the 5's because they're not there anymore. And then she rewrote this as x minus 2 instead of 2 minus x. Now, you can do that. We've talked about that in other conversations. You can do that if you're factoring out a -1. My concern here is there's no negative sign anywhere, right? She would have either had to have put the negative on the x right here, or she would have had to have changed that addition sign to subtraction sign. Okay, so she screwed up in step 2. Okay, but again, just be careful. If we kept going through here, she has made other errors as well. So you just want to make sure you find the first error. Okay. All right. In 2012, Elliot Nichols was awarded the world record for the fastest text messaging while blindfolded. Everybody needs a hobby. He was able to text 160 characters in a time that was 40 seconds less than the previous world record holder's time. Elliot's average rate of texting was 1.6 characters per second, faster than the previous world record holder's average rate of texting. At this point, lots of you have shut down, okay, because there's just so many words here. You have to really force yourself through that desire to shut down. What we're going to do is we're going to create a little chart and we're going to start putting stuff in here so that we can see it a little better visually. But you got to get through the question first, so don't shut down on me. Using the previous record holder's speed as x. Okay, that's important because that's our frame of reference. Okay, it's the previous record holder's speed will be x. Determine an equation that describes this relationship. Okay, so here we go. We're going to create a little chart. And we're going to talk about Elliot and the previous record holder. This is a distance, speed, time question, okay? We're not running, but we're texting, and it works the same way, okay? So the distance ends up being the amount of characters in this setting, okay? So the distance is 160 for both. You are asked to have the speed of the previous record holder be x. So that's why I stuck the x there. Okay, then you were told that Elliot's rate and speed are the same thing, right? Elliot's rate of texting was 1.6 characters a second faster. So I took the previous record holders and I added that 1.6. Okay, now your job in a distance, speed, time question is always to get 2 columns, and we accomplished that with this information right here. Okay, that was the 2 columns that we filled in. Where that third column comes from is the relationship between distance, speed, and time. Distance is speed times time. Okay, so if distance is speed times time, that means time is distance over speed. I can just divide both sides by s. Okay, so that's where I'm getting these guys here. I'm taking the distance and I'm dividing by the speed, I'm taking the distance and I'm dividing by the speed, okay? All right, now, the last piece of information that we haven't dealt with yet is actually what makes the equation, okay? Elliot's time is 40 seconds less than the previous world record holder. So this number is 40 seconds smaller than this number. Okay, so I have to create an equation from that. There's a couple different ways you could do it. You could go the bigger number minus the smaller number has to equal 40. You could go the smaller number plus 40 equals the bigger number. Or you could go the bigger number minus 40 equals the smaller number. All of those equations would set you up to solve correctly, okay? What you have to think about when you do this, because you really don't want to mess this part up, because it'll mess up everything else, right? Think about the fact that you have an equal sign there. By definition, whatever is here and whatever is here have to be the same thing. So that's why I'm saying, if you want to put the smaller number here and the bigger number here, well, how do you make that equal? Either you have to add the 40 here, so now they're equal to each other, or you have to subtract the 40 here, so now they're equal to each other, okay? Or you could go big minus small equals 40, okay? All of those would work for you. Now, what I chose to do is I went the smaller plus 40 equals the bigger, okay? All right, then we are going to use that equation and we're going to determine Elliot's texting speed. So we are actually going to solve this now, okay? So common denominator is going to be x times x plus 1.6. So either I rewrite everything as a common denominator or I multiply everything by x times x plus 1.6, however you like to do it. Okay, I chose this time around to just multiply everything by x times x plus 1.6. Okay, so when I do that to the first guy, my x plus 1.6 is divided each other out and I was just left with 160 times x. On the second guy, I end up multiplying by x and by x plus 1.6. And on the last guy, my x's divided each other out and I was left with 160 times x plus 1.6. Okay, now I want to distribute that. I want to distribute that. I'm hoping that you're pausing me as we go through here because I'm not giving you enough time to think. There's no reason for me to sit and watch you think. You're going to pause me and do it yourself and then come back and look at my answer. Okay, so when I distribute, I end up with 40x squared plus 64x and 160x plus 256. So now I do have an x squared and I have an x and I have a number, which means I have a quadratic that I'm going to need to solve. Bring everything over to one side. My 160x's can just go away because they're the same thing on either side. So I'm looking at 40x squared plus 64x and I'll minus that 256 so that it's on the left to join the others. Okay, I can reduce that, divide everything by 8. And I'm looking at 5x squared plus 8x minus 32. Okay, now I got to solve that. Okay, so I could try and factor, I could go to the quadratic formula, I could graph. If it's a written response and they want it algebraically, don't graph it. But if it's a multiple choice, any one of those would work fine. Okay, I chose to throw a graph in here. Now, we are talking about speed, okay? So I know that I can't have, and I know that the bottom fraction here represents the speed right now. So I know that actually my x value has to be greater than has to be greater than 0, okay? My x value has to be greater than 0 because I can't end up with a negative speed. So although I have two intersections here on the x-axis, I'm only looking at that guy because the other dude's negative, okay? All right, and so that is x is 1.85. Now, The next question you have to ask yourself is that's x. Is that what you were asked for? You were asked for Elliot's texting speed, so you got to go back to that cute little chart you made and you got to say, okay, what thing represented Elliot's texting speed? It wasn't the x, it was actually the x plus 1.6. So now you actually have to answer the question. Elliot's testing speed is 1.85 plus 1.6, which is 3.45. Make sure you have units there. In this case, with the texting, the units were characters per second. Okay. Awesome. Okay. The rational equation 2 plus x over x plus 2 equals 3 over x is solved for x using the work shown below. Which statement correctly completes the solution? So our statement options are x equals 3 and x equals -2 are both valid. X equals 3 and x equals -2 are both extraneous. X equals 3 is valid and x equals -2 is extraneous. Extraneous means it was an NPV and it doesn't work, okay? And x equals -2 is valid, but x equals 3 is extraneous. Well, to do that, that was a lot of words, but to do that, we need to know what our NPVs are. What can x not be? Well, let's go back to the original equation. X can't be -2 and x can't be 0. So -2 is for sure extraneous, but 3 is not an NPV, so 3 would be a valid solution. Okay, and so my answer is C. Okay, let me just clear that ink there. A contractor and a gravel truck driver arranged to meet at a sand pit 9 kilometers away. In traveling to the pit, the gravel truck's average speed was 25 kilometers slower than that of the contractor's car. The table below summarizes the information. So here's an example. This was a release item from a diploma. They did not ask you to come up with the equation. They gave you the equation, okay? So the equation is below. You need to understand that x is the speed of the car and x minus 25 is the speed of the truck, okay? Now, what are you doing with that? You want to figure out the speed of the car. Well, in order to figure out the speed of the car, we have to solve this equation. Okay, the equation was given to you. You just have to solve it. So we could multiply everything by 60 times x minus 25. That would get rid, that's our common denominator, so that would get rid of all the denominators that are there. Or we could write it all as a common denominator first and then pull the numerators. It totally doesn't matter. Okay, I chose to multiply everything by the common denominator, just to kind of do 2 steps in one. So I multiplied everything. I'm just going to write that here for you. I multiplied everything by 60x times x minus 25. Okay, because that was my common denominator. So that leaves me with 540x minus 540 times x minus 25, and then equals 4x times x minus 25. So if you're just trying to figure out where I got that, the first guy here, okay, when I multiply my x minus 25s would divide each other out and I'd be left with 9 times 60x. That's where that 540 comes from. 9 times 60 is 540. On the next guy, I have 9 times 60 again, which is my 540 again. My x's divide out, but I'm left with multiplying by x minus 25. And then the last guy, my 60s divided each other out. So I'd be left with 4 times the x minus 25. Okay, so now I want to clean this up. I want to get rid of the bracket. So I'll distribute that negative 540 and I'll distribute the 4x. Okay, bring everything over to one side so that you have a quadratic that you can look at. Your 540s here, 540x's can just go, right? They add up to 0. So you're just bringing that guy over there. Okay, so I end up with 0 equals 4x squared minus 100x minus 13,500. All of that's divisible by 4, so I could make my numbers a little smaller. Okay, and now I want to look at either factoring, either the quadratic formula, or graphing. Okay, I feel like I've forced you to do enough graphing in these last videos, so I am going to factoring, I meant. I feel like I've made you do enough factoring over the last few videos, so I will graph this. I know that because one of my speeds was x minus 25, I can't have a negative speed, so that tells me my minimum speed is 25, right? Because I can't minus 25 and end up with a negative number because I can't have a negative speed. So I'm only looking for the solutions that are greater than 25. I say that because if you look at my picture here, you can see that that's coming back up. You know there is some other point of intersection over here, but I can ignore that because it's a negative number. Okay, and so I get 72 kilometers an hour, and that was x, and x was, in this instance, the speed of the car, so that is the answer. Okay, the speed of the truck would have been 72 minus 25. Okay, last question. Abby and Eden drove 435 kilometers from Edmonton to Fort McMurray. Abby's average speed was 30 kilometers an hour faster than Eden, and she arrived in Fort McMurray 1 hour before Eden. Determine Eden's average speed for the trip. Now again, a question like this, I didn't give you any, I'm asking you to build the equation and to solve it. Your diploma would never do that to you, but I want you to be able to practice both items right now, so I'm gonna do it to you. That's how nice I am. Okay, so we're gonna start with a distance speed time chart. We know we're talking about Abby and we're talking about Eden, and they both have gone 435 kilometers. Abby's speed was 30 kilometers faster, so we'll call Eden x for speed, and we'll call Abby x plus 30. Okay, and then all I did was I filled in those first two, right? Once you have the first two, you get the other guy by the relationship distance equals speed times time. So my time is my distance divided by my speed. So that's where the 435 over x plus 30 comes from. And that's where the 435 over x comes from for Eden. Okay. Now, the one piece of information I haven't dealt with yet was that Abby arrives 1 hour before Eden. That means Abby's time is smaller than Eden's time, right? If Abby arrived 1 hour before Eden, maybe Abby took 3 hours and Eden took 4 hours, or maybe Abby took 9 hours and Eden took 10 hours, okay? The point I'm trying to make, going back to this conversation, is Abby is a smaller number. So you could go Eden minus Abby equals 1. You could go Abby plus 1 equals Eden, or you could go Eden minus 1 equals Abby. All of those would work, okay? Okay, I chose to go the bigger minus the smaller equals 1. Okay, so Eden minus Abby equals 1. Now I'm going to solve. So my common denominator is x times x plus 30. So when I multiply this guy by x times x plus 30, my x's divide each other out, and I'm left with 435 times x plus 30. When I multiply this guy by x times x plus 30, my x plus 30s divide out, and I'm left with 435x. And then nothing divided out here, so I'm left with x times x plus 30. Okay, so now I'm going to get rid of the brackets, 435 times x, 435 times 30, x times x, and x times 30. In this one, my 435s add to 0, so I just have to subtract my 13,050. So I have my quadratic to look at. And so that quadratic should be x squared plus 30x minus 13,050. I'm going to go ahead and graph that. I know that x has to be greater than 0. And so I get a root or an x-intercept there of 100.2 for x. Okay, 102.x for or 100.2 for x. And then I have to make sure I answer the question. It asks for Eden's average speed, and Eden was represented by x. So that is my answer, 100.2. If I was asked for Abby's average speed, I'd have to add 30 to that and say that Abby's average speed was 130.2. Okay. All right. So that is the end of dealing with equations and applications of rationals. And that actually is the end of rationals too. So you have now survived rationals. I'm hoping you're feeling better about rationals than you did before you started watching these videos. And yeah, so the next thing we're going to do is sinusoidal, I believe. So I will see you for sinusoidal and polynomials and all the other good fun stuff that's coming up. Okay, take care, guys.